everyone. Today, Kyeong Ra will be the invited talk speaker. To give you some introduction, up to very recently, Kyeong has been a cognitive and AI engineer at IBM. He worked at IBM for more than 3.5 years, also as a blockchain architect, senior consultant, and Watson developer. During his doctoral studies, he conducted various researches using machine learning algorithms for smart home and healthcare applications. And he recently has received the Client and Partner Success Award and General Manager Award at IBM. And today he's going to give us a talk on the topic of basics of AI and MLOps. And let's give Ho Kyung a warm welcome. HK, are you ready?
Yes, I am ready. All right, so here I start. So she gave a little, Dr. Yun gave me a little bit introduction about me. She called me HK, but that stands for Hogyang. And people have a hard time memorizing my name, so I sometimes mention names such as Hello Kitty and Hong Kong. And then they will forever remember my name. Now I kind of engraved my name into your brain. So if you meet me in person, you will remember me forever. That's good news. And joke on the side. So some of my experience that she mentioned that yes, I was working on a lot of medical health related applications during my PhD. And when I joined IBM, I was working for the Watson product. Also, I started as a blockchain developer, but I was working on a Watson product, which is a AI application, and it has a many aspect of AI. And then I was working as a cognitive and AI engineer because I guess the company wanted to use me a little bit more than just an AI engineer. So I mean the product engineer, product developer. So I will go in a little bit more detail toward my presentation. And so now my actual presentation begins. So I'm gonna talk about basics of AI and ML ops. This presentation that contains covers some basics, some advanced, and some current trends in the around the AI and ML companies. But I gave this same talk to the large companies in Korea, such as SM Entertainment. They have a lot of singers there, like Super Junior, EXO, Shiny. Maybe you heard them before. Or I also gave the same presentation for the Samsung Electronics and large bank financial companies in Korea for the who just started working as a AI engineer or ML engineer and a digital transformation team, but they don't have too much knowledge in AI. And I just wanted to give them little startup in their knowledge before going further into their journey in the company. And they really enjoyed it. And I hope you, everyone who's in this talk, enjoy the presentation. And now I will go into the presentation actual content, starting with I always start with this presentation PPT slide. The person in the photo, his name is Arthur C. Clarke. He actually wrote the story, and also the story was made into a movie called the 2001 A Space Odyssey. In that movie, there's a HAR, I think it was HAR 9000. That's actually a first ever presented shown AI solution in a movie at I think it was in 1968, and it was a sensational at the time because of the space or astronaut. The pilot was giving a mission to the chatbot named HAR, saying that open the door, and or I think it was a close the door or something, and then the chatbot or the HAR said that I'm sorry, Dave, I'm afraid I cannot do that. That was the response given by the HAR, and it was a sensational in a way that the AI chatbot was the first time shown in the movie, but at the same time it was disobeying the order given by a person. And at the time, people were like, "Wow, the robots can be or chatbots can invade the humanity," and that was the one of the worry that they had at that time. But I put this PPT because of not just that it was the first time, because of the author, Arthur C. Clarke. He stated that any sufficiently advanced technology is indistinguishable from magic. That's what he said. I like that sentence because when I first time experienced the supported vector machine, it's one of the machine learning algorithm. When I experienced it, that was very sensational to me because the machine learning, the mathematical solution or mathematical algorithm can differentiate color like red versus blue, or objects like with the feature information saying this is a tiger versus dog and etc. So it was a magical to me, and I always tell everyone that the data scientists, the data engineers, or even computer scientists or computer engineers, we are the magician of this time that we are living in, and you can create the magic out there that gives a very fun yet helpful experience to the users or end users or clients. So I always tell them to be strong with the field that they're walking in, and be always positive because there's always people see us as a magicians in the field. So enough of that. I ask this question to everybody: what is AI? And I know when I give this talk in offline, there's the children's or the high schoolers or even the engineers. They say that AI they see as a Jarvis from the Iron Man. That's from the high schoolers saying. And some other people are saying like it's like Siri from the iPhone, or Alexa from AWS, the chatbot solution, and uh, and Cortana for the MS solution. That's what they usually address when I talk about AI. They are not wrong, but there's more deeper meaning into the actual AI, and we're going to look into that together. So when I started the field of the AI or machine learning, I wish I had known this before. So this is kind of giving you, I wish I had known when I started this field. I never had a clear perspective or a hierarchy perspective of what is AI and machine learning. So I started off this the hierarchy picture, but I will go in more detail. But just have it in mind that there is a hierarchy which goes into from AI to machine learning, and then there are other type of machine learning algorithms in there. But when we say AI and machine learning, we're going to look into deeper. AI is like the machine learning is stated as a machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience, spoken by Tom Mitchell, ML department in CMU. So when I see ML, machine learning, although there are a lot of words saying in it, I would see that as like a mathematical equations or formula, and it's an algorithm that does a particular mission that is given to the algorithm. However, it still needs a lot of cleaning and data manipulation before and after the algorithm. So that's what we should see as a ML, machine learning is. And when we see AI, so again, Zachary Lipton, assistant professor and researcher at the CMU, he said that AI is aspirational, a moving target based on those capabilities that human possesses, but which machines do not. Again, a lot of vocabularies there, but I see a AI solution is like a solution that is containing the machine learning algorithm in it. So AI is like you can think of a speech to text or text to speech, or so speech to text is like a solution that when you say something, it translates into the text information, and text to speech is of course the reverse of that. Or the chatbot solutions, or image recognition solutions. We call that as AI. That's how I believe it. And machine learning is the algorithm that running in the back end of the server. So AI is more human friendly, whereas machine learning is more engineer friendly. That's another way to see it too. And when I talk about machine learning, so now we kind of have the perspective of what is AI in a sense. So it's closer to human with some kind of interaction, user interface, but there's something running in the deeper, which is a machine learning algorithms. So now within AI and machine learning, now we're gonna go into a little bit more about what is machine learning. And we need to think of, there are two things that I mainly concern and address when I talk about machine learning, which is one of them is a feature. And second one is I'll talk about in the next slide. So feature information is like the XYZ joint information from the human body, and the acoustic information that recorded by a microphone. And now when I mention Hello Kitty, Hong Kong, now you probably know that I'm telling about me, HK. So that's kind of a feature information that I say that can help identify or classify the characteristic of the mission or the subject or object that is given. So it can be an image information as well. So now that you have a feature information that used for training, and you use you need to create a model which used for machine learning algorithm. There's many ways to create a model, but when we talk about model, people usually think of, oh, it's just a random solution or result by a certain tool. But when we talk about model, model actually, if you open up that model file, it actually contains a mathematic formula along with a coefficient number on it. So I think that most of us know what is linear algebra, y equals mx plus b. So I'm trying to give you the example of a supported vector machine in linear, which is shown on the left figure that is currently number is changing. So the purpose of that is trying to create the best divider between the green dots to the red dot. And through many iterations, it finds the best slope and the best intercept, so mx plus b. So in here, that m and the b coefficient, and also the form of the equation equal the y equals mx plus b, that actually gets stored into the model file. So same thing goes for the deep learning. Deep learning also contains certain equations such as the weight and bias information and how the perceptron on the node is constructed through the different layers of the network layers. So that information gets stored into the model. So when you open up the model file, you will see a lot of numbers, but you can kind of have a sense that inside a model that kind of equations are there and the kind of numbers information is stored in. So that's the two things that you should keep in mind about the machine learning algorithms, feature and model. So now you can understand the hierarchy perspective a little bit better here. So the AI contains the machine learning, and the machine learning contains the supervised, unsupervised reinforcement learning. And these supervised, unsupervised reinforcement learning, they are different type of the algorithms. And then supervised learning includes classification, regression, unsupervised learning, clustering, reinforcement learning, MDP. So by the time when I got onto this PPT, I usually see people drawn off to their phone or off to the other web browsing. But I just want you to remember that maybe just have a perspective in your mind by the end of my talk and when you leave my talk today. So that when you actually go in, so I'm kind of giving you the center of the snowball so that you can build a snowball that builds top of each other. And so when I give a talk, they said, what is supervised learning, unsupervised learning, reinforcement learning? That was also the confusion point. So inside of AI, ML, supervised learning, you should think as a children, like teaching what is a banana, what is an apple. Unsupervised learning, think of like recycling, like plastics together, glasses together, papers together. So you are not labeling them, you are kind of just seeing them and putting them together that is likely to each other. That's like unsupervised learning, like clustering. And then reinforcement learning, people often get confused this with deep learning. Reinforcement learning is like a game where one character wants to get one point A to the point B without dying, but we do it with a many trier in training so that they actually wins the game at the end of the many triers, and we just need to find the one of that. And if you ever seen I know I'm just a big fan of the superhero movie, so if you have seen an end game in the movie, there's a character named Doctor Strange. He goes through 400,000 cases or some kind of large number of cases, and he said, Iron Man, there's only one case we can beat the Thanos, and then that's, you can kind of imagine the reinforcement learning as. So although that's how we see the hierarchy, but in real life projects, you just don't throw in the AI into the project first time that when you start the project. Usually the project managers or the project PM, project manager and project leaders, they looking into the project thinking that whether this actually requires artificial intelligence or not. So they're looking into if this can be resolved by business logic development or through a mathematical statistical modeling. So if this cannot solved by these two the method, then that's when the AI kicks it in, and then type of the machine learning algorithm is chosen from the data we model, and then we create a classification model, and that goes to the solution, and we create AI solution. So that's how the project usually starts. So it is very important for if you are first time employing the AI into a company, it's very important that the company, the project managers that understands a little bit of a machine learning or a little bit of AI before even discussing the employing the AI into their company. So that was one thing that I always address when we talk together with my clients, and then I make sure that they get up to a certain speed of the understanding of machine learning, and then we go on with the project. But really, though, in reality, this kind of roles, there are existing roles in AI related projects, and I saw this figure. It was individually in a separate images, but I put them together in one PPT because I thought it was interesting, and I made it like a game. So if you see that there's NLP engineers, conversational designers, data engineers, data scientists, data analysts, machine learning engineers, there are many AI roles, AI project roles. So during the time of the studying, one may want to concentrate on NLP a lot deeper, or data engineering perspective, or data scientist perspective, or machine learning engineering perspective, and so on. And they require different different ability or different concentration is needed for depending on which role they take. But conventionally, that from my experience from the company, that I've seen that a lot of data engineers and data analysts. So I would say they were and they are the ancestor of the data scientists and machine learning engineers. And I really I hear their stories, how they have done things without knowing what is machine learning or AI algorithms, and it was really interesting. And then I tell them, oh, what they have been done, you can apply this machine learning algorithms, and then I show them the result, and they were wowed. So things we are learning, although that there were conventional ways of doing it, but there is a better way of doing it, and they were very excited about it and surprised about it. However, just keep that in mind that there are these many type of roles, although we call it AI. And please don't get discouraged that, oh, I cannot get a role as a data scientist because I didn't go through in very detail or in very depth over the data scientist. There's so many roles out there, and always don't get hindered by that you want only the data scientist role. And actually, the machine learning engineering role is getting very famous too. So that anybody who jumps in right now, I would say they are not too late, and we are the engineers, and we will keep go forward. So please stay on the track and don't go to the side, and you will be able to get to the point where you want to be. And this is type of process that we usually have for the actual AI project. So you put the client, they create a RFP saying that we need someone or some company or consulting company comes in to do our AI project. And on a proposal, this is type of usual process that we write in our proposal. It's called the CRISP DM, which is cross-industry standard data management process. So it's a type of a methodology. But how it goes is then it starts from the business understanding. So we understand the problem first, and then understand what kind of data they have, and then we prepare the data, and then we do modeling. And the modeling, the result goes through the evaluation process, and it actually deployed to the service. But as you can see, this kind of do follow the agile process. So it's very fast process between the iterations, and then the entire iteration gets run one more time at the end. And the same process goes over again and again and again until they actually have the fine working solution. So let's look into each process. And so if you're looking at the business understanding, what the important thing or person in this step is SME, subject matter expert. SME is very important. I heard that there's a role as SME in CDU, but in here the SME is the actual project, the subject matter expert. So so if you know how to drive, you are the subject matter expert on driving, and so just like that, that's very important because then you can actually understand the problem, and with knowing that not just the SME is important, but also they need to, or the project members, they need to have a somewhat understanding of what is AI and what is the machine learning algorithm, and what is a statistical way of the machine learning algorithm in a little, actually just teeny bit of that, so that they can scope the project and they can direct the project to the right direction. And um, and after that, there are so many areas that this AI can be employed, such as entertainment, education, government, weather, investment, and chatbot solutions, and so on, and even in the finance sector. So business understanding is very important. So people who is actually pro at a particular field along with AI knowledge, they tended to be the lead of the project. And then after understanding the business, also data understanding is very important, which is exploratory data analysis process. In here, I placed these images because they looked very pretty. No, I had that thought in my half of my heart, but my half of heart actually was wanting to tell you that this is a standard type of graph that we see when we actually see the comparison between the feature information. So we do pair plots, we do correlation heat maps, and then we do box plots and another type of graph in order to understand the characteristic of the data. So pair plot, so these are just saying that you plot them and you see the phenomenon of a data, and then you use that information for the machine learning training. And just keep that in mind. But if I just want to give you a little bit of some idea, is that I think this is a age versus tax. So I'm not sure what this data was from, but it has a correlation of 0.51 in a positive perspective. So that's 0.5. That's mostly almost random, but that's how you see the correlation heat map. But after seeing that, now we move on. So we understand the business, we understand data. Now we need to prepare for data, and then we do modeling. In data preparation, that's basically the data engineers kick in and they help you to get the right data. And usually there's a lot of process if you are actually working for the company, because it has a lot of PI information, personality information, which is very, it has to be stored away very securely because it's a private data. And that usually goes through a lot of processes within the company, and then you actually get the information and you use it to the machine learning training or modeling process. In a modeling process, I haven't mentioned there's a supervised learning that I mentioned as SVM, which try to differentiate the blue dot versus red dot, or depending on what your goal is. So the data transformed, so like even string information is transformed into the number information, and then you create a classification in it. And then, but mathematics, put that aside, because a lot of data scientists or actual algorithm developers, they already worked on creating the algorithms. So for us right now, what we can do is, as a data scientist, we can actually know how they work and use them in our actual practice. And I just want you to know that you shouldn't be scared of using machine learning algorithm. It's very simple and straightforward. So I try to just show you the main skeleton of it. So in a data preparation process, you prepare the data like X, train data X, and then label them Y. So in here would be, if you classify apple versus strawberry, you would put like a color information and how curvature are of the strawberry, say 0.5, and then apple will be color information and how big the or how the weight of the subject is, and then say an apple. So data and then class of the data, and it's prepared like that. So that's X and then Y, and then you choose an algorithm that given from the library, and then based on the library, we call a training function name, which is a fit, and then we call it test function name, which is called the predict, and then you can classify whether this is apple versus banana. So it's mainly like a 3-step: choosing an algorithm, and then put the training data, call the call the function name, and then call the testing. So it's that easy, and that easy to create a model. So I hope that the person that everyone in here that who is into the programming first time, I hope that no one gets scared of doing the programming. You just gotta know the large perspective first, and then just open up a little bit by more every time that you work on, and then expand a little bit more, and that's all you need to do. And there's nothing more scared about it. And then the another question I get is, then okay, can we just use one model? Can it solve the entire problem that we have? That's partially correct if you are using deep learning, but mostly we have different type of the algorithms, because you can create different ways of dividing the data set. So in dividing blue versus red dots here, you can kind of see that there is a ways of dividing data, like with the KNN or linear SVM that I talked about. So y equals mx plus b, that if you just remember, it's a linear way of dividing the data points, or in a kind of like a rectangular form or circular forms, and etc. So there are many ways to draw a line between data sets. That's why we have a lot of supervised learning algorithms, and it's just, if you step in furthermore, it gets even more interesting if you see the mathematics side of it. But just to seeing, I just wanted to show you the pretty picture. At the same time, I wanted you to know that there's many different algorithms because of this reason. That's why we have it here. And the unsupervised learning that I talked about, it's a clustering algorithm that you gather plastics together, glass together, paper together. And in here, we chose k equals 3 to show that there's 3 different clusters. Okay, so that was what is the supervised learning about the conventional algorithms, like machine learning, conventional machine learning algorithms. But if we are talking the machine learning algorithms, you got to know that deep learning, also convolution neural network, that also falls into the category of the supervised learning, because you present a set of images with a label on it, so such as a dog, cow, or horse. So we put it's not that hard also for convolution neural network. So I'm trying to, I hope I don't lose anybody here, but let me give it a shot. And here we go. So for convolution neural network, you put an information image, like a graph or the image of an input image with a certain label saying this is a zebra. And then in here, with a lot of convolution network, which extracts a feature information. So if you see here, it gets some type of the edge informations and color informations and etc. So through this feature map layer, so there's a total of 2 different layers in convolution neural network. First layer, you just dump it in the image, and then you get some type of a feature information. And then that feature information gets flooded out in a single array, and then the information gets fitted into the fully connected layer. And then actual classification happens in the FCC of the fully connected layer. And then the output of it, it gives you the like a confidence type of number, but it's a softmax activated the result, which say that might be a horse, that might be a zebra, that might be a dog. Because our input was a zebra, it has a high number, which is the 0.7 here. So convolution neural network, yes, it seems complicated, but if you actually open it up, it's not that complicated. That's what I wanted to tell you. And this is a very famous GIF image of identifying the handwritten digit information. So the 1, 2, 3, 4, 5, 6, it has a data set, has a 0 through 9 with the handwriting sets, and that each pixel information is fed into convolution neural network, which goes through the feature extraction layer, and then it goes through a fully connected layer, and then in the back there is a small boxes which gets triggered that shows it whether it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there like that. There's a many ways to get to that each nodes, but there is a probabilistically model that gets that if these pixels gets triggered, then it should be 1 and it should be 2 and 3. So that's how CNN works. And if you put that into the code, it's not that complicated either. So I'm kind of trying to put this image into the code so that people can kind of see in programming how it would work. So in the neural network model, you have a convolution 2D, max pooling, convolution 2D, convolution 2D. So these three blocks are this part where you do feature extractions. And then you flatten it out. And then you call this 2 dense line, which creates a fully connected layer. And then at the end, we put another dense layer, which is the output. So if you see the image to the code, it's not rocket science. And please don't get scared. That's another thing I want to say. And it's just like that, similar to the SVM that I showed, but for the deep learning, it goes similar. You just replace the chosen algorithm with this coding block into there, and that becomes the model. And then you call it fit function, and then you call it predict, and then you can get the result of it. So even deep learning, convolution neural network, it's something that it's not scary monster. It can be easy if you break down step by step. This kind of showing how the data gets classified. This is like I have seen this data set. It's the life expectancy of the battery data set. So in company, if they want to estimate the how battery performs over time, if this battery is almost reached to the end of the life, I heard that this data set, it looks like the spiral data set, and it's trying to classify whether the battery is healthy or not. So that's kind of the data set they have, and we have input. Like 8 neurons, we have input here, they have input here, and then 8 neurons and 5 neurons, and you can see that the classifier gets created correctly after certain iterations. So knowing that this is some of the well-known convolution neural structure, like a VGG19 or 34-layer plane, and so on. And it's just that they stack up a lot of nodes layer on top of each other. That's why it looks so complicated. But if you look at the individual node, the complication is very little. So don't get scared. Once again, I say so many times because so many people get scared over the AI and ML algorithms. But if you see in detail, if you see in a very microscopic level, it's really not a rocket science. And then this is one of the other example of the single shot detection or you only look once algorithm. This is the algorithm that used to identify object within a given image. And a lot of many industry AI applications that I have seen, they use a YOLO to identify the actual product within given image. For instance, there was an insurance company, they wanted to see if the moped or the motorcycle is used for delivery or not. So they were checking whether there's a delivery box attached to the motorcycle or not. Depending on that, the insurance company was able to give out insurance or not on the given image because the delivery motorcycle tended to get in a more accident where the personal use ones less in accident. So that was one of the example of the YOLO V5. But I'm just sharing that that's one of the examples that that the algorithm gets used for image identification. And if you see the example of running it, oops, I think it's too loud. So the YOLO V5, it got trained, and they were just showing the camera to the YouTube video to see how well it defines. And YOLO V5 algorithm successfully identify truck versus car versus a person, and it gives the confidence information on the right with a frame per second as about 30 FPS. So I gave this talk to the parents group of the children's of the elementary school, and they were saying that can they make this a miniature version to monitor whether their children is on the desk or not. That was their question to ask. I told them I can't, in a loving heart of children's, so that they can have fun. But yeah, this can be miniature created, and there's a lot of application already been used on the CCTVs. But that was just one fun incident that I had in a talk. And another thing about so up to there was about the SPM, I'm sorry, the supervised learning. But reinforcement learning is a little different than the supervised learning. It's like as I said, it's a given environment and you give an action and the agent takes an action and then you see a result of it. So in that multiple cycle, it gets success. But back in 2011, IBM wasn't actually used the reinforcement learning in the Jeopardy game to win the game. So that's just a fun fact to know. But so maybe this kind of gives you an idea of the reinforcement learning. So in each frame, there are, yes, this is a Pac-Man, but I guess they were trying to avoid the copyrights. I think they kind of manipulated the new images and so on. But this kind of gives you an idea of how reinforcement learning works. So at each stage or at each frames of an image, the character, the agent, the I would say the Pac-Man is trying to understand that the ghost will move to the right, move to the left after observing the entire environment, and then the character wins without dying. So that's kind of an idea how the reinforcement learning works. Besides that, there's another machine learning method named the federated learning. This federated learning is type of a learning that so for example, if you're using iPhone, you are not actually sharing the keyboard keywords that you typed it into the screen keyboard, but you are actually sending in the data of weights of the information. So like a coefficient number that I said. So more than sharing your personal information, private information, that information that you use to be used for the trained in a product will be the weight information more than your personal information. And the federated learning aggregator, it doesn't get any PI, but it just gets the coefficient numbers. And then it aggregates the information and then it fuses out again to each machine learning application so that the model can employ that newly built model on their mobile applications or the server applications. So that's another way the machine learning method that federated learning exists out there. So now this kind of encapsulates or captures the whole image of the what is supervised learning, unsupervised learning, and reinforcement learning. And keep that in mind, the reinforcement learning is not unsupervised, no supervised, nor deep learning. It's just something else. And that's where I want to just nail it before we move it on. And reinforcement learning is like a mission problem solver. So keep that in mind. And we have an evaluation process and deploy as a service process. And during the evaluation process, the usual score that we look is the ROC curve or AUC curve or the F1 score. So ROC curve, of course, the left elbow, that left upper elbow, it's kind of the pretty graph that we want, and F1 score getting nearer to the 1, and that's kind of we want. And we don't want overfit or underfit classifier. So if you remember the linear classifier that I was talking about, y equals mx plus b, that is a very simple straight line. So if you have a very simple classifier, it may not able to classify the other outer data points. But if you have a too complicated the coefficient model, then you may overfit the information that some of the data that shouldn't be classified an apple or banana will be included as classifying as a banana or apple. So you want to avoid that. And what you want is the somewhat okay model complexity with not overfitting or underfitting error. So just keep that in mind. And so now I want to give you the auto AI or auto ML demo. So nowadays, some of the actual clients, they do not have an expert or a data scientist. And they ended up saying, is there just simple click way of creating a machine learning model? And we say, yes, there is, and which is auto AI. So in here, we are trying to create on the demand, bicycle demand in South Korea, depending on hour and temperature or the weather information, see how many bicycle gets rented out in the given period, so that they can kind of measure how many bikes should be in the city, out in the city. So it's just a standard process of choosing a data. So first we just kind of give it the model name, and then we choose a data set that I just shown, like bike training data set, 2020 bike training set. And we're trying to create a regression type of the model. And there's many type of the metrics to be measured, or many type of the algorithm that person can, the engineers or data scientists can choose. And then they simply run the experiment. And just like that, they can have a model executed and start training. So it gets the data information, 90%, 10% data hold out. So 90% data gets used for training, 10% data gets used for testing. And the platform chooses, or the AI, auto AI chooses what type of algorithm is best algorithm to be used. And then it goes enhancement, such as hyperparameter optimization and feature engineering. That's something that the model is required. And it measures the errors and see the least errors that is the best algorithm that gets selected. And happen to be, it sees that XGB regressor is the best algorithm, and it can be used for deploying the model. So just like this, there are many auto AI solutions out there. And in here, you can see that what kind of feature information have been used. So there was been feature engineerings here and there, and you can actually save the model to be deployed as a service later. So some of the product out there and some of the problem, you may not need to even have a coding skill needed out there. And you can kind of quickly see the result turn out too. So, and then the service, of course, needs to be deployed as a service. There are many ways of deploying as a service. What I just showed you is a commercial product. That's why it can be easily deployed as a service. But most standard process, they generally follow CI/CD process through Git, Jenkins, making as a container runtimes, and so on. And they usually, the modeling is done through the Python coding, and then capsulated with the Django or Flask, and then it goes through the Docker Kubernetes to the container service and gets deployed as a service. But as I said, some of the existing product out there from AWS, Azure, or even IBM, they have deploy service for you instead of doing all those containerization doing manually. So depending on the company's choice, you may have to go full on open scale, but some companies actually choose this type of ML platforms to deploy models as well. And I'll just move on to that one. And after you deploy as a service, also nowadays another concentration is that is very important is that I think a lot of countries, they demands the companies, if they employ AI models, they need to have a certain standard which looks into the quality and fairness and driftness of the data set or model, and also the result needs to be explained. So these metrics also be very important. I would believe that it will be soon to be very important in the near future. And for just say like driftness, and I know there are some other metrics that I've explained, but for driftness is that over time, the data set change. So age group population might change, or the weather information change over time. So if there's that kind of a drift in a data or the classified model result, then that's the time when you need to recreate the model or retrain the model. So that's why it's important to train the monitor the driftness of the model and explain abilities like due to what feature informations, whether this information is classified as A or B. So that's some of the explainability that industry is currently looking at together. So that was existing product out there called OpenScale from IBM, but that was some of the screenshots that I was showing. Basically, the feature informations can be used, altered to see what was the mistake that the person have done that classify it as A or B. So there are many existing platforms or products out there. That's another thing to keep in mind. So it's my 45-minute into talk. So now I'm gonna go into the actual AI applications out there. Now that I have gone through in detail about the ML process and what is ML and what is AI. So there is a project named StyleGAN. This project actually, so the face on the left, they are actually existence of a face in the Earth, but this face on the right, they do not exist in the anywhere around the world. So they are AI generated faces. So GAN stand for the Generative Adversary Network, which means that I believe that the first purpose was trying to attack the AI. That was, I believe, that was an initiative, and then now we have a style again, or even called the DALI. So if I show you a little video clip for a second.
Have you ever seen a polar bear
Sorry, I'm
playing
much
bass?
too loud.
Or a robot painted like a Picasso? Didn't think so. DALI 2 is a new AI system from OpenAI that can take simple text descriptions like a koala dunking a basketball and turn them into photorealistic images that have never existed before. DALI 2 can also realistically edit and retouch photos based on a simple natural.
Yeah, so it's basically with the NLP, deep learning, and neural network, and with the image, it can create some kind of image. That's what this is about. But not just this, the OpenAI or the OpenAI group, they are also working on the coding as you input information. So let's say type, create a Google search page, Google like a search page, but title with HK. Then you will have a Google look like a search page. Actually, the HTML coding is done with the HK as a logo. So that's something that lately that been caught up on the media, and that is current trend that people are looking into, the generative adversary network again. But so I just for fun, I put onto the DALI, I typed in CDU of Seattle logo, and this is what DALI says. So it was kind of interesting because it looks like a blue, looks like it was trying to create Space Needle. I know it does not quite resemble the CDU image, CDU logo, CDU of Seattle logo image, but this is what I have seen. So just to show that how the GAN is a thing out there. And there's also a lot of other products, that AI products out there too, like NLU product, which Project Debater, it actually gathered all the opinions by people around the world, and it actually summarized it, and also it clustered the opinions together. So this many people said that. So maybe I should show you a small video clip of it.
Into for and against. Next, the technology identifies the recurring key points, ranking them based on their quality and their frequency. Finally, the AI creates a coherent narrative of the strongest and most prevalent of the key.
So let's see.
The following analysis used AI models to identify the critical key points made by each side. 56% were for redistributing wealth, with 20% currently inequality has increased dramatically over the past few decades.
So like this kind of a topic clusteration and then summarization is done by the NLU solution. So that's also another example of the usage of the NLU solution. And there's a STT and TTS type of product. And maybe if you are iPhone user, maybe you have seen the weather channel. Also, it's the IBM product, but in here, there's a lot of AI solution running behind that we don't see as just users, but there's a lot of other metrics, like metrics such as golf index or soccer index, basketball index, tennis index, and outdoor picnic index, and so on, or the asthma index, and so on. So all those kind of index was done by the AI modeling and ML algorithm modeling. So yeah, so I'm now 15 minutes into my talk, and I should give us some time to get a question being asked. So if it's your time, everyone. And Dr. Yoon, maybe you can take over.
Thank you, HK, for a great talk. Let's give him a round of applause. I hope everyone enjoyed this talk. If there's anybody who has questions, please turn on your camera when you ask the questions. Does anybody have any questions?
I don't bite. You can ask any questions. Well,
I have a quick question for HK because
sure.
you started with one of my favorite authors.
Okay.
And the ethical issues that Arthur C. Clarke was talking about, what are the modern day ramifications for those ethics?
Right. So that's very good thing to address. That's why, okay, so if I go back to some of the PPTs, so I was talking about the fairness. That's one thing that lately they caught on to in the industry. Many people talk about, is this AI model safe? Is this AI model secure? Of course, there's more other stories that we hear saying, for example, if the Tesla sees a human or a baby, should that car run over a baby, or to protect the driver, or should the car drive off the bridge to protect the baby? So there's that kind of ethical questions there too. But I think that's a little later on. There will be more answer to that type of question will be come up in a philosophical manner. But as of right now, in an actual practice, what I don't know if I can mention the company name, so I would say like a credit companies, they ask when the credit card gets issued, they have ethical issues. They're saying that there might be a fairness or gender discrimination or race discrimination, or for employment. Currently in Korea, we now I left. They have used a lot of AI model to classify the resume using the AI model. So the blob of resume gets into the model, and then based on the certain informations, the AI text NLP model and classifies he's qualified, she's qualified, or not. That's what it is. So due to that, because of the ethical, I think the government and the industry, they're trying really hard. But as of right now, the only thing that I have seen is the fairness monitoring, which try to see, as a word itself says, be fair between the classification A group to the B group, or bias group to the non-bias group. That's one answer that I can give it to you right now, but I don't know if that's enough.
Thank you. There's always going to be that human factor.
Right. That's always that issue. Okay.
Adrian, would you like to ask a question?
Yes, I have a question.
Yes.
I guess under the umbrella of AI, you had mentioned its application in the medical field.
Right.
Do you have any references that I can go to read up on that? Because I'm kind of interested in that, how that it can be applied to, let's say,
Okay.
to biotechnology and medical research.
Okay, so good thing. I'm actually seeing myself on my camera, so I'm trying to. So if you go to Google Scholar, oh, I think I typed it wrong, but okay, Google correct me. I'm not sure if you can see my profile. Like I have all my the what do you call all my publications here. They, like, if you can see, there's a asthma guide. I am a smartwatch, smart enough to know the accuracy of my own heart rate sensors. So I have these papers. Maybe you can look me up in Google Scholar. So
Okay.
maybe if that can maybe help you.
Okay, I can do that. Thank you.
You're welcome. Any other questions? Just to quick sharing my because we have now 3 minutes of presentation left. I just wanted to tell you that if you started late, I'm trying to go to thank you page. If you started late in this field, please don't be discouraged. because of there's a young ones that they started earlier. I just think that we are engineers and we are developers and we are mathematicians, or we are the actual builder, like a Lego builder. If you put enough time into it, I believe we can accomplish anything that it's in front of you. So I know it's hard if you are working and doing school together at the same time, but I just want to say that never give up, because you will get to the point where you want to be, as long as you never give up and put enough time into it, and try to not to do all at once. Divide them not equally, just divide them small bit each day. And I always believe in divide and conquer. So please stay strong. And if you are discouraged lately because of I have seen a lot of my friends saying that they've been laid off due to the recession. That's sad, but they always stay positive. They always make fun of the company, saying that we were too good enough, the company, that they couldn't provide support us, having us in the company. And so if you are discouraged because of a particular events you are going through right now, or if you are discouraged because you started too late, I believe in studying and specifically in engineering, nobody's ever late. That's how I believe, especially our area. And just keep strive forward. And I know that you will get to the point that you want to be one day or tomorrow. So I wish everybody best of luck. And I think that Dr. Yoon looks eager to say something. So.
Any final questions? You can ask him not only on AI but maybe on his work experience at IBM, career, anything about career. Any final questions?
By the way, just to remark, it's been about a week and a half since I left IBM because I had to come to US. So right now I'm on a job market as everybody is, and if there is any openings, shoot me a mail. Maybe maybe I'll go for it too. So self advertisement here, but yeah.
Oh, there's one question.
Okay, who ask?
Oh, my bad. That was my kiddo. I'm sorry.
Oh, no problem. Okay, if there's no more questions, I think we can end our the talk here today. Thank you everyone for coming in and joining us for this talk. I hope you enjoyed it and learned a lot from it. Thank you. Have a wonderful day.
Thank you, everyone.
Thank you.